we have the lookup, and we can use a ramp. So this might be a quick, well, this is a quick way to create your own interesting textures. Now we're getting away from simple shapes such as circles, rectangles. We're going straight into noise coloring. And we're gonna modify a ramp. Maybe something like this, saturated, kind of dark. And we're gonna add a second color. Yeah, let's also make it a dark one, but we're gonna go the opposite end, and we're gonna add a light color in the middle, which approaches white. We can do some slight interpolation, add some flavor to it. Maybe this red is not the best choice. There we go, something like that. As you can see, I started with something like as a simple noise pattern. I animated it, and then I'm using lookup and a ramp to create a texture which can be very useful, and we're going to see this later on. It can be very useful to create textures that are interesting. This could easily be some sort of wallpaper or some interesting form of animation that you can use as a background to just about anything. Well, if I multiply this by a circle, I can come up with an interesting, well, I can start to come up with an interesting generative composition, and I can animate this or have some sort of interactive sketch. There's really a lot that we can do with these textures. So that's about it when it comes to tops. We've checked out generators, effects, we've seen different types of compositing, and we've seen how to integrate all these textures with chops for channels, numbers, and data streams. We're gonna move on to SOPs in the next section as we start transitioning towards 3D. Whenever we work with SOPs, we have to start thinking in 3 dimensions. We're no longer stuck on a grid or on an image. So let's maybe check out a sphere real quick, because we have all these SOPs that we can select, but they're going to be very similar. Now, if I activate my viewer on my SOPs, you're going to notice that it's a bit different. We can see the sphere on 3D, and we can move around. In fact, we can navigate by rotating and orbiting using our left mouse click. We can drag up and down to translate in space, and we can move up or down, left or right. And then we can use the middle mouse click to drag and zoom in or out, which is useful. Navigating in 3D can be a bit awkward until you get used to it, so I recommend giving it a try and doing it as much as possible to jump in as fast as you can. Now, that's the thing about 3D. However, it's important to start going in, getting used to how you work with SOPs. And one very useful object for this is the line object. And something useful here are the display options. If I activate my viewer and press P, I'm going to be able to see my display options, in which I can see points. I'm going to be able to see normals and UV point texture coordinates, whatever's available. Nothing too exciting for lines, but I definitely want to see the points that I have. And in this case, I only have 2 of them. Maybe let's set my first point in my coordinate -1, 0, 0, and my second coordinate is 1, 0, 0, 0, 0. Remember that we're in 3D, so we have negative x, positive x, z, which is our other transversal axis, and we have y, which is vertical. So this is really important. In this case, maybe I want to use a larger number of points. As I add them, you're going to be able to see that they start to show up, but maybe I want something like 200 points, which is something more exciting to work with. If you ever want to go back to the default view, just press H with the viewer axis, and we have this. Now, we are used to working with chops, and a chop that we saw briefly while explaining noise, but we didn't really go into, was the pattern chop. The pattern chop allows us to select different types of lines, different patterns, as its name implies, that we can use as data in other operators. In this case, I'm going to use the sine pattern. As you can see, this is a sine wave, which is very useful for creative coding, just a cycle that goes over itself. And we can use this to displace this line, which brings me to a very useful SOP, which is called the chop2. And this is important to mention. The chop2, dat2, all the different objects that end in 2 are gonna be conversion objects. You're gonna see that we have a chop2. We have top. We're gonna be able to see that there's in this case there's also a chop2, and if I'm correct, like dat is the one that has the most of this, because we can also have different ways of converting, like SOP2s. We can have chop2s as well. It's important to convert data between different types of operators. In this case, we're gonna use the chop2 because we want to convert this data into something that allows us to transform the points that we have in 3D space. So we have our line, and right now I have no input chop. So I want to add it by simply dragging it, and it added it automatically. However, I have an alert which tells me that there is no channel TX, TY, and TZ. The way this works, the chop2 is going to tie whichever channel I give it to any parameter that I want to get. And we haven't really seen that, so remember that the documentation can give you information on that. But we're going to use a dat. Remember that those were our data, our information operators, and we're going to get the info on our line. Oh, my bad. We're going to be using, let's do a SOP2. Not really info. Info actually has a different purpose. So let's drag line to the SOP2. And we can see a few parameters that we can use. And we have P0, P1, and P2. Those are our 3-point coordinates. You might be able to see other ones. Index is quite useful, but more often than not, you're gonna be using points. And in this case, what we're gonna do is perhaps rename our channel to TY. And we're starting to see something quite useful. We have displaced our points. We don't really need any of the other ones, so we're gonna get rid of our channel scope and attribute scope, that we're not gonna use anything but P1. And in this case, we're gonna set the pattern. Well, we know we have 200 points, so we're gonna set our pattern to be somewhat shorter. And you see that as I approach 200, I start to see the whole sign. I can always zoom out to see it. Let's actually set the pattern to 200, and we can have a whole cycle. I could potentially reduce the amplitude, and maybe it'll be something a bit more subtle. And I could add many cycles, and I should be able to get, yeah, maybe 5 cycles. And our line is going to be following this pattern here. It's very useful to have. Again, nulls are going to be the key to keep our networks organized. So it's one way to do it. Experiment with different patterns. You're going to see that if you use different ramps, different triangle waves, if you throw in some randomness, you're going to be able to displace our line in space, and you're going to see different options from it. One that I really like is a square wave, which are, well, you're basically getting some pulses out of it. It's a lot of fun to play with this. Keep an eye on what your geometry is, on what info you can get from the geometry, and how you want to transform it. That's going to be the main thing. Now, line is not the only thing that we have to work this, and in fact, Touch Designer makes things very easy for us. The easiest way to get started with different shapes is by using what Touch Designer calls primitives. We have different generators in this case, which are going to be our primitives. We have our box, which is, as its name implies, it's simply a cube. We have the sphere that we saw earlier, so we could check out our coordinates. We also have a grid, and I'm going to show you this. Well, I'm going to compare this with a rectangle. Remember that this is not the same thing as the rectangle in the texture operators. This is a rectangle in 3D. So we have a rectangle in space. Now, our grid, and I'm going to check both viewers just to make sure that I can really see them clearly. These two figures look just the same. However, whoops, sorry about that. However, if I enable my points on the grid, I can see that the grid has many points as part of its structure. The rectangle, on the other hand, only has 4 points. So it's important to know the difference. Your rectangle is only going to be, it's basically one polygon, or maybe two, depending, well, it can be 2 triangles usually, or maybe 1 rectangle, depending on what you're using. A grid is usually be a combination of many points, which means you might have a lot more geometry happening in it depending on what you've done with your grid. So that's really important that's really important whenever you're working with 3D. A few other fun shapes that we have are the torus, which is nothing more than a donut. Make sure you play with different parameters, like that you change the sides, the different sizes, different parameters for each one of them. They all have their own panel, and since these are primitives, you don't have that many options. The idea is that you get started with them, and then you start manipulating them through your network. So that's the way you work with them. And we also have a tube, which is essentially a cylinder. You can select how high you want it to be. Maybe check different radius if you want them to be the same or maybe not. Plenty of options when you want to work in 3D. And went too far. Now, the important part is that you're going to be working with these figures in space, which leads me to one of the most important SOPs, which is the transform SOP. It's very similar to what we saw before with our transform top, but in this case we're working in 3D. So it looks a lot like, well, you're always going to have components with 3 coordinates. Say in this case, we were using frame for rapid rotation, and well, that's translate. We're going to use rotate. You might find that this is pretty annoying. You see how the camera is like bouncing back and forth. It's useful to just disable homing, adaptive homing by enabling your viewer active and unchecking this box from the viewer, because otherwise it can get pretty crazy, particularly if you're doing some pretty extreme transformations. You can do that. You can rescale your box to create something more interesting. Maybe you want to translate it, and this is something that you can do. Well, if I just set a counter like Apps time, my box is just gonna fly away in some super high coordinate value, so maybe I don't want to do that. But if you've ever worked with Python, you can always use Python expressions here. In this case, it could be something like math.sign, and we're gonna throw our apps time there. If you've ever worked with Python, this is simply a sine wave. I'm just not using a chop for it. Maybe I want it to be a bit smaller. We'll get some slight moving up and down. This somewhat of a, well, you know what? We can change this into a platform that moves up and down. And yeah, this is pretty exciting. So yeah, these are SOPs essentially. We're gonna be using different primitives. You can transform them. Make sure you experiment with translation, rotation, scale. One that is worth checking is uniform scale, which is really the same. But whenever you get a shape, you just make everything larger or smaller. It's the combination of these three, but instead of like using one axis for the scaling, you use all 3 axes. Maybe do 1.25. It's slightly larger one. So yeah, that's the important of these ones. And another thing that is worth checking out is booleans. In most of our operators, we've gotten to a point at which we want to merge or combine or composite our data or whatever it is that we're working with. Geometry is no different. Sometimes we're going to want to put things together. So maybe let's throw a box and a sphere together. And using a Boolean operator allows us to combine this geometry. However, we have to be careful because object B is not polygonal. So in this case, I have a polygon, which is the box, just it's a combination of polygons, but our sphere is a mesh. A mesh is a somewhat different structure, so we're gonna select a polygon. In this case, it starts working. Now we have a union, like you have different types of combinations, and we're starting with a union, but I'm not really seeing much. That's because my sphere is pretty much covering all my box. It might be useful to enable the comparison if you can't quite see what's going on. In this case, not even then. So what I want to do is make the sphere smaller. In this case, it could be something like 0.7, 0.7, 0.7. And as you can see, I get a bit of a custom shape that combines both of the previous SOPs. My sphere looks a bit weird, so I'm gonna add some detail. I have a frequency of 2. If I keep adding frequency, I'm gonna get a better looking sphere. But now it's a bit too close to the edge, so maybe let's change the size of the sphere to be more like 0.6. And there you go. That's a That's a pretty nice one. That's something I like this combination. We can copy this network. We're gonna place it below. And we can see a different type of combination. Intersect is simply grabs the combination of this two, but it only uses the space at which both have geometry. As you can see, I get this weird shape that only uses the geometry from the cube and from the sphere. It's very close to only include geometry that only include the space where both geometries are present. However, this looks very weird. As you can see, this union, I'm getting sort of an idea of lighting, of depth, and you can see sort of a light that I'm not really using right now, but it's a nice preview. In this case, I'm getting this shape that it's all dull, and that's because this resulting shape has no normals. The normals in geometry are the ones that determine how lights react to whenever they hit our object. So we can create normals by inserting an operator that's called attribute create. And we're gonna ask this operator to compute normals. And that's a lot better. We keep moving on with these booleans. We're gonna grab our network again. And this time we're gonna do a minus b. And this should be interesting because now I'm subtracting geometry one from another. Similarly, I'm getting that dullness but on the inside of the shape now. So let's see if we can do something about it. Same drill. And now I can actually see inside of the shape, which is great. We could potentially reverse the, well, let's just copy the, wow, sorry about that. Let's just copy the whole network, but instead we're gonna reverse this geometry. We still have our attribute create and all, and that's quite interesting. Now we have 4 different little somewhat sphere segments that are made of everything but what the cube had. So it's an interesting way of thinking about geometry and creating a creative way of coming up with geometry. And one final one that is quite interesting and not very common. Let me get rid of this. I'm just gonna copy this 3. One interesting way of working with this is finding this last edge. And whenever you're talking about edges, you know what? Let's actually reverse this again. And whenever we talk about edges, well, this is a Boolean operation that is not present in every framework I've worked with. You're basically getting just the edges of the shape. You know what? Let's grab the attribute create and see what happens. Yeah, much better. But yeah, these are edges, so it's an interesting way to create circles in space. So yeah, that's Booleans. Whenever we use the Boolean operator, we're putting shapes together so we can create our own. Make sure to experiment with different ones and try to think about the ones that make sense. Perhaps using a sphere and a line would not really make much sense. A sphere is a 3D shape, a line is more of a sequence of points, it's more of a 2D idea. But if you use something like a sphere and a tube, or maybe a box and, well, 2 different boxes, there's a lot that you can do with them. So make sure to experiment with them. And to wrap up SOPs, And to move on to our 3D workflow, I've set up a few extra examples that I'm going to include in the pack. There's the text SOP, which allows you to basically write, but remember that it's in space. So rather than being limited like we were in the previous text top, the text top was just an image, 2D. This text is effectively geometry in 3D. You can see that the text is being transformed and moving in 3D. We also have trace, which is a clever way of turning our images into geometry. Take a look at the points and try to take a closer look at each one of the figures as you transform them. It's definitely worth checking out. What makes the difference is this threshold whenever you're using trace, because it's what's gonna select the geometry to include from our image, and that gets converted to geometry. Again, it's geometry that can be transformed and that you can do all sorts of stuff with, and we're gonna see more of that in our 3D workflow that we're gonna see just next. And now we're going to create a 3D scene in Touch Designer. The way to do this requires something a bit more than a SOP. Well, the SOPs are going to be at the heart of this workflow, but for this type of workflow, we do need comps. And comps are, well, like its name says, components, and they're containers that include all the objects that I'm going to want to highlight in our scene. We're going to get started with geometry, but keep an eye on all the other 3D objects. You might be able to read this even though it's a bit hard to spot. But these are all 3D objects that might come in handy while you do this. We're not going to use all of them. In fact, I don't ever use all of them, but it's useful to know they are there. The geometry comp holds our geometry. If I go in, I'm going to notice that there's a torus in there. I'm going to get rid of this SOP, and I'm going to replace it with a sphere. And instead of just displaying the sphere, which to do that, I'm going to make sure I have a second layout, a second pane on the right side of the screen, because I want to be able to monitor what my geometry sees at all times. Right now, my geometry cannot see anything. So I want to display it, and the way to do that is to use the display flag, and I always keep the render flag just in case I want to monitor it. This is really helpful if I ever want to view what's going on, or use my or maybe enable different options that Touch Designer has available to allow me to monitor my workflow. But I don't want to do this in this sphere node. Like I was telling you, nulls enable me to keep my workflow organized, so it's better to just enable these flags right here. And I have my geometry displaying the sphere that I added. So that's a good start. Again, the nulls also going to allow me to introduce additional operators if I need them later on. So it's really the best way to work with them. Now, whenever I work with a 3D scene, there are three things that are absolutely needed. You need a camera. You need a camera. You need a render top. Render is basically the engine that is gonna create the scene for you. And in this case, unless, well, say for a few very specific examples, I'm probably gonna need a light again. So we have a light, we have a camera, we have geometry, and we have render taking care of everything to make sure I have my scene right here. And well, maybe I wanna make sure that my camera is positioned in a different spot. Let's see if I can go to my camera, and on the pane I can see that it resembles a lot like what we saw on the transform tabs of many of our SOPs. So maybe let's set it on 4, 4, and 5. And what that means, as you can see, I just made everything disappear. And a very useful camera to see what's going on is the geometry viewer. Just select it from our top left drop down for different layouts. And I can see that our geometry is in the middle. And you're also going to be able to see your camera and your light. So keep an eye on what's going there. You have your scene. We're gonna go back to our network editor, but I think it would be really useful to keep our geometry viewer right here on the right side of our screen. Maybe that's a good layout to work right now. Now, the problem that I have right now is that my camera is on the right position. I want it slightly above and to the right of our object. This is the default position. This is where we have our camera. We have it 4, 4, and 5 because its depth on the Z axis is positive. If I were to move this towards the negative edge, you're gonna see that the camera moves behind the sphere. But I don't want to do that right now. The problem is that our camera is not really facing where it should be facing. And to do that, there's a very easy way to do that. I could easily just tweak the camera, make sure that I can rotate it, and maybe try to move it around, but that's a bit more work than you need to. And funny enough, comps have a null object as well, which I'm just gonna make smaller because this is just gonna be a target. In fact, I'd like to rename this as ncam target. And this is a point. Well, null is basically an empty container for now, but I'm just going to use this as a target for my camera. If you take a closer look at my camera comp, I can use the look at field to set the camera's target. And again, I can see my camera right there. Maybe it's a bit hard to really know the difference between my camera and, well, having moved it because I'm looking at a sphere. But let's say I'm going to duplicate this geo, and I'm going to replace the sphere with a box. Now the problem I'm gonna have is that now I have both objects in the same spot, so I cannot see the box. But I'm gonna translate this box to say -2. And now I can see that my camera shows me that I have a bit of a top right view of my scene. The circle looks a bit big, so I'm gonna take advantage of uniform scale and maybe, that kind of makes it look a bit closer to maybe 0.65. So that's better. I like that. And before I go on with this, we're gonna start building on our scene. So maybe let's add a couple more objects. We have a box. I think maybe we should add let's add a tube just to see what it does. And maybe a bit higher. No, maybe not. Maybe I don't want it to be that wide. And the thing about the tube is that now it's basically on top of our box. So I want to move it to the other side of the sphere. That looks better. That is pretty good. And well, now I have a hollow tube. If you've been playing around with the SOPs, I would recommend perhaps investigating the cap SOP. And let's take a look at what this does. Whenever we add the cap, it's gonna close the end caps for my object. We just need to know, okay, cool. So as you can see, I added a cap by selecting the U axis, the U coordinates, and there are different types of it. You can use a faceted cap, you can use a rounded cap, whichever you'd like to use. In this case, I'm gonna go for faceted. And you might notice that this is a bit weird looking, and that's because my normals are all a bit, well, a bit weird on this particular one. So I'm gonna go back to my create attribute. Again, that's the value of my null. I can just keep adding stuff to my network without having to connect more stuff at the end. So I'm computing the normals with my attribute create like we did before. And that's pretty useful to have. In fact, I'm gonna add this attribute create, which is gonna be useful later on, to all of my networks. If you've been planning ahead, perhaps this is something that you can copy and paste with your whole geometry, but no reason to skip steps right now. And we saw that this hasn't really changed for other, that the normals didn't really change anything for other figures, but that is fine. And finally, I'm gonna add one final geometry, and I'm gonna do this as a grid. Grid is important because again, it's just a surface with many points, and I'm gonna set it on the ZX plane. It seems like it disappeared, but that just happens because our default view is horizontal on the x-axis, so we cannot really see that. Well, this has no dimension on like vertically, so it would be hard to spot it that way. Now that I've moved it a little bit, move the viewer in my geometry. Remember that the viewer in my geometry is not my camera. They're different things. And maybe I want this to be a bit larger. In fact, I can see the grid start to show. Let's try 5. That's a bit better. I'm gonna go all the way to 8. Perfect. And I don't want this to be cutting off the shapes that I created, so sure, this is quite nice. 1 works. We don't need it to be completely flush with the figures, but this does do what we need it to do. So this is our 3D scene first. The light is also something that exists on your geometry viewer. As you can see, it's right here, which is why all of our objects have the light coming from the front. So maybe I'm gonna set it off to the side and up. So let's do -4, 4, and maybe a bit closer, 6. And keep an eye on this. Whenever you're working with light, it might have seemed like the camera was doing nothing, but that's just the camera view. Keep an eye on the actual render. The render is the one that's gonna show you what's going on with the lighting of your scene. If I'm gonna undo it, I have the objects all showing the lighting from the light from the front, but then I've moved my light again, and I'm just undoing and redoing stuff. You can see that it's -4, 4, and 6, and I have this nice lighting coming from top left that is showing that my 3D scene is right here. And this is our 3D scene so far. It's quite a simple idea. There's plenty of more stuff that we can add. We're gonna talk about materials just to wrap up the session, but play around with the lights. You can have different types of light. You can add shadows to it. Remember that in case of shadows, you might need a cone light or a distant light, but that's a bit beyond the scope. We might check that out on the advanced session next week. And now we're gonna move on to materials. So let's get rid of all of these geos, which we don't need anymore. And the final step is that we're gonna explore different types of materials in our create dialog. Right now, we have our geometry, which is simply this white plain geometry sitting in the middle of our scene. But what if I want a different look for it? Materials are what's gonna allow me to use this. And to get started, we're gonna add a constant material. As you can see, it removes pretty much all lighting. As far as we can tell, this is a circle. The only reason why we know this is a sphere is because we can go all around it and still a circle. There's just no lighting to let us know how it curves around itself in 3D. So, well, in any case, if this is something you don't particularly need, if you just need something like an indicator screen or something very simple, constant material might be everything you need. Whenever you come into material, check your pane, and you're gonna see all the options that you can change from color, maybe yellow or blue. Whenever you do have alpha, but we're gonna have a problem here. Whenever you add alpha, you need to enable transparency. You need to add blending, which is part of the common tab. Just add the transparency, and your alpha is gonna start to work on your figure. We can see some weirdness here, like it's I would not really recommend using constant for this type of thing, but it's good to get started with our materials. Well, another way to see our geometry is the wireframe material. And if you've ever worked in 3D, it just shows you how your geometry is built, but it's very useful if you want to give it somewhat of a sci-fi look, more with lines, more of a grid idea. This is very popular if you want to do something something with a very specific aesthetics, like very popular in the 80s, let's say. So wireframe is simply, well, it's very similar to constant, and we can just change the colors that we can get from the wireframe itself. But that's about it. It doesn't really give me a lot of options. So what happened is that recently they added a line material, which is far more exciting. As you can see, it's very similar to a wireframe, but I have a ton more of options through these tabs. And what I want to do is play around with these tabs to do something interesting with our render. And maybe I want to get a bit closer to the camera because this is a bit small. Sure, we're starting to get there. We know that we're at 334 on our camera, and this is going to be really important. This is going to be really important for our line, because the line has distance as a major consideration and something that we have to work with. Think about two things. You're going to have a line and certain settings for your geometry that's close, and you're going to have a line settings for your line whenever it's far. Let's make it very noticeable. Whenever I'm near, I want it to be bright, and I want it to give me this blue look. Whenever I'm far, I want to have more of a darker blue color. Something interesting is happening here. We can see that I have a more interesting type of look. I'm gonna set the distance far to I'm gonna give it a somewhat large number, and I'm gonna play around with my near distance. Maybe, there we go. As we can see, distance near allows me to set this blending between my two colors, the bright one and the darker one. It went a bit too low. Let's maybe set it to 2. Now the width near, maybe I wanted to make it a bit more subtle. And the width far, I can't set these lines to be a bit more wide. You can go crazy with it and make them really, really fat, you know? But remember to be checking your render, because the geometry is not really gonna show you the changes. Maybe that width is a bit too much. So let's set it at 5.5 or something. And the far distance is gonna be, well, let's go from distance near from 0.8, and distance far, we're gonna bring it a bit closer, maybe around there. There we go. We can see that we're slowly going from our distance close, which is bright in front and darker in the back. And remember that this distance is in relationship to your camera. So that's, you have a few more options to this. I would recommend experimenting with them. But for now, we're also gonna maybe see the points. You can draw the points. You can show them in your geometry. And you can give them a color, maybe something like blue. Blue is good. And that's one way to give your geometry a different type of look. Maybe you might want to see vectors, and the vectors are related to your normals. Definitely want to scale them down. You see this more spiky look. And you can also have, well, if your geometry were to have caps, you can also use that. I don't really think we're gonna go into that with a sphere. So, and that's about it. Remember to enable transparency if you're gonna be using alpha. But other than that, that's our line material. Quite useful, very interesting to work with. You can see that our material preview shows you how a geometry with these settings would look. But for now, let's get rid of it. We're gonna move on to the next material. And whenever we're working in this 3D setting, it's important to start to think about lighting and about how photorealistic we want something to be. So just to get started with lighting, we're gonna go into Phong materials. Whenever you work with Phong materials, which seems to be the default material with our geometry, we're looking for a somewhat accurate model of how light and our geometries interact with each other. So we have our Phong material, and our Phong has additional color options, as we can see. So we could give we'll give it a diffuse color, which is just a constant color, how our material's gonna look without, like, regardless of the lighting. But we also have options like specular, and specular is how our geometry interacts with the light itself. We can make this really bright, and you can see that I have this really bright spot. We can also tweak the shininess if I don't want it to be too pronounced, or if I want it to be just an absolutely reflective material, which maybe I don't want to go too crazy with that. 25 is good. You can also use emit maps for different types of light. Constant, which is just going to add constant light to your material, but that kind of defeats the purpose of it. So for now, I'm just going to avoid it. And specular, I'm just going to scale this down to 0.7. I want this to look reasonably bright. I'm going to move my light a bit further away. And we can see that this is what we have so far. This is quite nice. You can add normal and bump maps. We're gonna get into that a bit more in the advanced session, but those are a lot of options that are fun to play around with. One type of lighting that is really fun to play around with is the rim light. Whenever it comes to Phong materials, you can select, maybe let's do something quite noticeable. So this bright red, you can select the angle at which it hits your light, and you can almost make it look like a secondary light. You can add its width to make it really pronounced. You can make it really strong. And maybe this color was good as a reference, but I want to be a bit more subtle about it. And now that I know where it is, I'm going to bring this strength down. Maybe the width a little bit. And we take a closer look just to finally tweak it. Maybe a bit, there we go. On the opposite side, gives it a bit of a glow, which is fun to work with. You can add another rim light. So you can have this, well, maybe a bit too bright, but yeah, it kind of gives my sphere a bit more of a complicated look, like if I had multiple lights, or you can see that we are getting a more realistic type of thing. So play around with Phong, see what you can do with it. Remember that this one also has blending, but I would recommend experimenting with these parameters. Phong can be quite a fun shader. And finally, we have the PBR. Whenever you're working with PBR materials, and this is kind of it looks like a weird material to be working with because all it did was dull down my sphere. Well, whenever you work with a PBR, you want to add something else to this. PBR material, it's that's a type of material you would use for something photorealistic. It's whenever you want to give your geometry something like a physical type of look. In fact, this is called physical based rendering. So what you want to add, the way Touch Designer does that is using different maps. And these maps work really well whenever you add a substance generator. This substance is nothing more than a collection of maps that you can use for photorealistic rendering. So maybe let's select something like metal. And we're gonna add this metal as a substance top, which we can find in our maps as well. Just you can either add a whole substance, which is gonna add all of its maps to the material, or you can add different maps, which are nothing but textures. If I have a texture, like say a noise, I could add it as an individual texture or to any of these fields. In this case, I don't really need it. And the way this is gonna work is that I'm gonna select my substance, and I can tweak the look of the material in its input values. For example, I can change the saturation, maybe set the metal color. I want perhaps something a bit brighter. You can see that it's a far more complicated look than what we had before. Whenever you work with this type of photorealistic thing, you might want to consider more lights or perhaps a nice background. In this case, it's also telling me that a material is normal mapping, but I don't have tangent attributes. But conveniently, I've been using attribute create for my network, and all I have to do is compute tangents for it. In fact, I would recommend inserting the operator called texture, which is gonna allow me to, well, I'm gonna see if I can select something different so we can go into, no, that's fine. So we can see that our material starts to look better and better, particularly once I add the tangents, because the texture has a better idea of how to apply the lighting and how my material is gonna react to my environment. And PBR is great because after that you can start to tweak additional parts of the material. I can give it more of a matte look or something really shiny. I can play around with the roughness. What if I want it to be a really reflective material or not so much? Find something in between. The ambient occlusion is tied to your environment, where we might talk about that later on. And after that, it kind of behaves like a phone light, a lot like a phone light. So maybe just maybe nothing too wild on the rim light. There we go. Rim center more to, let's go towards the other side as well. And just very subtle, quite subtle. And that is our PBR lighting. Make sure to check out the different types of substances that you can add. There are metal, checkers, wood. One that I really like is called the strawberry swirl. As you can see, it doesn't quite fit with this type of rim light, but there's plenty you can work with. And in fact, you can also download Substance Designer files, which are mostly free online, and you can definitely experiment with more realistic materials, with the realistic looks. It's a great way to set up your own 3D scenes. One thing you might notice is that in Touch Designer, more than a realistic rendering, we're going to be working with real time and interaction. But PBR is a great way to get a cool and interesting look without having to put too much effort in how you render assets, or without having to spend too much time on what you're doing. So that is quite valuable. And that's about it. Well, this has been our first lecture with the basics in Touch Designer. This is a good way to get comfortable with this type of framework, with starting in 2D, 3D. Make sure to experiment and to try to create your own example. I'm gonna make available an example pack for you to dig into the examples that we've seen and a bit of the concepts that we have reviewed. Make sure to be prepared for the Q&A session where we're gonna address any difficulties or any questions that you might have. And stay tuned for the second lecture, in which we're gonna review a few additional techniques and more advanced concepts so you can really start to play around and do your own thing with Touch Designer. I think it's gonna be quite exciting. Stay tuned and I'll see you next time.